Here's the deal. What you're seeing now is the integration of the whole course. This is the roller coaster ride of all courses. You know what I'm saying? All year long you've slogged away and you've done all these things. And what was it all for? Well, now you're finding out. Chapter 6, factoring, relates to Chapter 12 and 13, where you're finding the parabolas, graphing them, and finding the roots. And what you'll find out later in life in calculus is that you can actually start to measure the speed that things change and accelerate. You're not there now. We're only in 2 dimensions. This is a number line, guys. We did that in Chapter 9. This number line is where you find disjunctions and conjunctions. That was 1 dimension. Now there's 2. Chapter 7. This includes graphing. Lines, parabolas. Parabolas are in 2 dimensions because of the square. So what you're seeing here is all kinds of movement, and movement through space and time. And that's what mathematics is. It's the matrix of the entire universe. All that is structured, all that is real, at least as far as what you're seeing here is all kinds of movement.
Take 3, Mr. Day's algebra class, final exam. Algebra class, final exam.
Chapter 10, FERP 2, that's the final exam review package number 2. And we're on number 1, 25 minus 9 over x squared over 5 plus 3 over x. Now, the first thing you want to do is actually eliminate these fractions up here. Let's multiply the whole thing by x squared over x squared. Okay? In other words, we're basically multiplying the entire fraction by 1. That x squared is going to multiply on there and onto there. We're going to clear that fraction. And that x squared is going to multiply onto that 5 and there. And we'll be able to clear that fraction. And that's the kind of the logic of it. So, because the lowest common multiple, the LCM of x squared and x is x squared. See? And these are the fractions that are bothering us at the moment with the x and the x squared. So, we go ahead and we sort of basically do our rainbows there. Oops. Rainbow and rainbow. And this one is sort of rainbow and rainbow. Look at this thing. Peacock feathers. 25x squared. And this is minus 9 over x squared on to x squared. And this is over 5x squared, right? Plus 3 over x on to x squared. There we go. So, you see how that x squared goes into 25 and the x squared goes into 5, and that's how it works. So now we're going to go ahead and take this one step farther. That is going to simplify, and that is going to simplify as well, but not quite as easily. So this is going to be 25x squared minus 9. Okay? This x squared goes into x squared is 1 over 1. This 5x squared, okay, stays the same, plus 3x, because this x went into x squared, and we left x over, so 5x squared plus 3x. Now we're down to a relatively simple situation.
Difference of squares on top.
Oh yeah, see now this is where it's going to work out quite nicely, okay? We use that in the distributive property to get this. Use distributive property right here. That's what we did. That's why we have the rainbows, okay?
What portions? Property.
Okay, that's what this was, the distributive property. Now, we've simplified things here, and we've got some stuff going on here which we can simplify. 25x squared minus 9 is 5x minus 3 and 5x plus 3, difference of squares, factoring. And then down here,
you could take an x out.
That's right, and we end up with x times 5x plus 3. It looks good. Looks like we can simplify, and we certainly can. That's 1 over 1, which is invisible. And we've got a final answer of 5x minus 3 over x, ladies and gentlemen.
How'd you get
X squared equals 121. It's kind of like what we've already done, but a different way of looking at it. Completing the square on page 583, 13-2 is another way of solving these quadratic equations. It's just another way of solving it. So x squared equals 121. What would we do on this one to solve both sides? There's a couple different ways to do it.
The radicals.
If we take the square root of both sides, we get
x equals 11.
Plus or minus 11, remember? Oh. See? And the other way to do it, if we go x squared equals 121. Girls, okay. What's the matter? You okay? You need to go out? Okay, Taylor, please. X squared equals 121. So if we subtracted 121, this is another way to do it. We'd get x squared minus 121. equals 0. Remember that? And then we go x minus 11, x plus 11 equals 0. And guess what? It only works if it's x minus 11 equals 0 or x plus 11 equals 0. And that means we get x equals 11 or x equals negative 11.
So basically the way we did it was faster.
There's two different ways. But do you see the link between this way and this way?
Yeah.
Okay. It's this is what we were doing before, remember, in factoring chapter 6? And these are the roots. Again, I'm not going to do another parabola, but that's, remember? So this is plus or minus. These are roots. Now, let's take a little more complicated question. Solving, this is by completing the square. Let's say we have x plus 3 squared. All right? Well, that equals x squared plus 2 times 3x plus 9. Now, do you notice the pattern? We've done this before, okay? Do you notice that this middle term, okay, the middle term equals 2 times the square root of the third term. Okay? Now, the square root of 9, look at it, it's 2 times the square root of 9 is equal to 2 times 3. And there it is, 6x. So that's just a pattern with completing the square. And it has to do with trinomials. Remember we had trinomial squares when we factored x squared plus 6x plus 9? That's a perfect square, okay? And the square root of x squared is equal to x. Those trinomial squares, and we went, oh, okay, that's x plus 3 times x plus 3, which equals x plus 3 squared. It's a special type of factoring we did. Now we're looking at it from the other angle. Well, let's say we have x squared plus 10x, and it says complete the square. Now just complete the square. How would we complete the square here? X squared plus 10x. X squared plus 10x. Completing the square, well, what do we have to do to make this a trinomial square? Take half of the middle term, half of 10, equals 5, and square it. That's the key. So x squared plus 10x plus 25.
And then if you come to like 5 and 5, and then we do that.
And then the whole answer is just x plus 5 squared. So, but to get that, we had to do this thing called completing the square. It's like deceptively simple, but it's basically taking half the middle term and then taking that and squaring it, and you get the perfect square. And now, how does this work? Okay, well, if you get a question, you won't really get that kind of question. You get something like x squared minus 4x minus 7 equals 0. So you're given this problem, and this is another method to solving it. I mean, you can't factor it, right? Because the factors of 7 won't equal 4. And you can do the quadratic formula, but completing the square can be quite nice too. So how do you solve by completing the square? Well, we know we want to get a perfect square out here, but we don't have one. So what we do is we add 7 to both sides. We get x squared minus 4x equals 7. And we still don't have a perfect square, so what do we have to do to get it? We forget about this for a minute. What would make this, okay, what is half the middle term?
X minus 2 is 2.
Half of 4, yes, that's right, is 2.
X minus 2 is
And then 2 squared is equal to 4. So we just add 4 to both sides. All right? So we're going to get x squared minus 4x plus 4 equals 7 plus 4. So we're not worried about this too much as long as we just isolate the perfect thing here. And now this is x minus 2 squared. And we've got equals 11. And that's okay. Now how do we solve this? We're still trying to square root both sides. And we get x minus 2 equals plus or minus square root 11. And we're not quite done until we solve for x, right? So we add 2 both sides. And yes, break down. X equals 2 plus or minus square root 11. And basically now we have our 2 roots. X equals 2 plus square root 11. And x equals 2 minus square root 11. Those are our 2 roots.